command processor. So if you're going to talk about that.
Yeah, I mean, I'll talk about all the commander and one different piece because full handshake between the whole thing. So these are the high level things that these guys do. Now UI backend, we can, it's slightly easier to talk, but we'll come back to it once, So what is Skybridge? Why do we need registry and discovery, right? So like we said, whenever a Stargate comes up, and before we go into the handshake, the way they run, this is important also, is we run them, so we have hosts on the internet, where we run CD Cloud VMs. Some of them might be same host, some of them are actually different hosts. These are all vCloud VMs. And inside that VM is where we run all of our services. Okay? And all of these services also run in a clustered mode. There's multiple Skygates, there's multiple Skybridges, multiple SkyMaps.
Part of a single cluster?
Part of the single cluster. And the way the clustering is maintained is the same layer of code that we use for Ensemble in Star is also used in Skynet. Actually, that's another key piece. The Skynet also runs as an equivalent code where the picture is similar. Skynet is basically there's etcd, Ensemble, but the different layer here is called CML, the cloud management layer.
I see.
And what CML is, just like we said, OpenStack service maintains the state of all these processes, GML maintains Stargate and all other platform services sort of thing. This guy manages all the, Skygate, Skybridge, SkyMap, all these processes. It is basically in the same business. If some process, it monitors the state. When any process dies, restart, same location, different location.
It monitors platform services and zero stack services.
Okay.
There are no open stack services to monitor here.
I see. Yeah. Because you're not exposing this cluster for external compute or
This is
storage.
our
SaaS platform.
Okay.
Right. So we basically realize that the same thing of keep these things up and running, part of it, is like also needed there. Now the way the external world interacts with this is with the URLs, registry.zerostack.com and console.zerostack.com. Okay, and the way these things work is we have HA proxy also running, which fronts the requests for any people or processes that are running on the Star. So there's the two different interfaces are really users, which is browsers, or Stargate. These are the main guys who are talking through this, and this guy then dispatches it to the cluster of Skygates. There's more of these, or it goes to a cluster of SkyMaps. Okay. And HA proxy is the fronting for this one. And HA proxy also runs in multiple locations. So if one of them crashes, we fail over to the other guy. We use the virtual IP to switch it over, so we get high availability out of this URL.
Now there's no leader election or anything there. It's just good.
Yeah, leader election and everything is below this layer. These guys don't do that thing.
No, for the proxy.
For the no.
HA proxy, no. HA proxy is just a standard server load balancer.
Oh yeah, okay, fine.
Yeah.
Yes, a load balancer. We're just using it for availability plus load
Just
balancing.
TCP HTTP load balance
Okay.
connections. That's all it does.
So at a high level, that's the philosophy that there's a front-end load balancer. The reason it can go to any one, because there is no state in each of these things.
I see.
Right.
All the state lives in below this layer. So like we said, Skynet is one state manager, which manages state. The other thing is Skybridge, which is also a cluster service, actually uses etcd as a state for its own registry and discovery.
What is the point of Skybridge?
I'll tell you. But what I was pointing out is it directly uses etcd as opposed to going through this thing.
Okay.
Because Skybridge is a distributed discovery service, and it needs a distributed storage to store information. So if one of them crashes, you can still discover the information from the other person. And the way to do it is just use a distributed key value store.
I see.
ATC is used as a distributed key value store in this sense. Now, going back to the original handshake of what happens, right? What is the sequence in which things happen? So when we talked about two different interfaces. One is users talking to it, one is Stargate talking to it. Let's focus on the Stargate talking to it, right? So when a Stargate comes up, it's hard-coded with a URL which says, where is my discovery service? Okay, it's called SkyBridge address.
Okay.
And the URL the parameter that we hard code for SkyBridge address is multiple things. Okay, in a production system, it's hard coded with registry.zerostack.com.
Okay.
In internal systems and dev and everything, we have multiple of these running here. One is called Jenkins1.registry.zerostack.net. Another called Jenkins2. There's one more called devconsole.zerostack.net, which is our staging. So the infrastructure level, we'll come back to it. But at a high level, it has a SkyBridge address. Okay. And this, let's say if it's hard coded to registry.zerostack.com, right? As soon as it wakes up, the first thing it does is locate Skygate for me. This it sends to SkyBridge.
Okay.
Okay. And the idea here is you go to the discovery service, say, okay, where is the data stream processor I should be talking to? Okay. So the registry itself is the one which arbitrates this thing. And what the registry has is, this is a SkyBridge. It has an etcd backend, which is used as a key value store. It looks up from the key value store what is the Skygate it should talk to. As of now, it just picks a random one, but over time, the idea is that based on customer ID, based on load, based on a lot of other factors, you decide which data processor you want to hand it off to.
Maybe tell them how a new Skygate registers also.
Yeah, I'll come to that. So this guy basically sends a locate response.
So once it's picked, it's stuck with it?
Once it's picked, it keeps talking to it unless there's a disconnection.
In which case it will reinitiate a locate.
Yeah, there's two levels of algorithm here. What it does is, for some programmable number of times, it'll go try to talk to the same guy.
Sure.
And if that guy doesn't respond after so many number of times, it'll go to the discovery service again and try. If that guy is also done, it'll keep retrying.
Okay.
So there's two level hierarchical retry loop. One is retry same Skygate,
And then retry.
and then there is a retried locate.
Okay.
Outer loop. So whenever there's a disconnect and that network is bad, it periodically wake up and keep trying to poll these guys to find the service it wants to talk to. Okay. Now once it gets a Skygate locate response back, and by the way, this is all over TLS. It does HTTPS
Okay.
to do this. When it gets a response back, then it goes and says, okay, whatever is the response, set up connection with the Skygate that it needs to talk to. Okay.
This is a persistent TCP connection that we'll set up between the Stargate and the Skygate.
Okay.
If things don't go bad, it will remain in place.
I see.
So that all the stats will flow over it, all the events will flow over it, any commands will come back over it, whatever. It's a
Okay.
one line from star to sky.
Okay.
And this is the one that's talking to the Skygate process, which is doing all the, like we said, message log and database and all these things.
Yeah.
It's basically whatever it's sending there will go to that thing.
The reason to do this is, I assume, efficiency, so that you don't have to. What is
So
this?
why we do only one connection? Yeah, I'll go into that also.
Yeah. Okay.
So that's what I'm saying. That's the library that we wrote. I'll go into why we wrote a library as opposed to just doing HTTP post all the time.
Exactly.
So this actually talks HTTPS.
Okay.
To the outside world. If you look between Stargate and Skygate, if you put a proxy, it should just look like HTTP and HTTPS.
Okay.
So it doesn't with a post body in it. And the body has a bolt.
Okay.
So what really happens is when we send an HTTPS message, this guy takes it, he opens it up, he looks at the size of the body in content length, reads all of these and expects a bolt in it.
Okay.
Based on the route you send it to, right? So there is the basic route that Stargate talks to Skygate is on Skygate address / Stargate data. This URL basically expects a post request with a marshaled bolt in the body of the post.
Okay.
Okay. There's a few other URLs like status and all the other things. Now in the SkyBridge that we talked about, right? It basically has
Those are, status is on port 2999 and
No.
Star.
On star,
Yeah.
correct?
On Sky it's different. I'll explain that also.
I saw you guys have a port mapping.
Yeah, there's
File.
there's a
File
constants
with a-
file and there's a
yeah.
text file.
Yeah.
Ports we use, we've listed them.
So the SkyBridge, what it does is whenever you get a locate request, it'll send back a response with registry, right? But how does it know where are all the sky gates and who's there? So right now, the way it's done is every time any sky gate is started by StarNet, Skynet, it sends a register message to this guy.
It is also started with the SkyBridge address, just like how Stargate is started with the SkyBridge.
Oh, so it's the same
not
interface.
ported.
Everybody, no,
Not the same thing.
not the same interface, same address, same high level address, but it uses an internal port. So this is not available on the internet.
Okay.
The public requests go out on the SkyBridge. In the locate request, right, this is a locate request, this is a register request.
Okay.
Register is done on an internal server, it's not exposed on the public
I
server.
see.
Locate is done on the public server.
Okay.
Okay, and the reason this does a register is that as soon as you can just keep starting Skygate processes, and they'll all come up and automatically just register without having to this guy manage. In future, we'll do more sophisticated things, which is basically this guy will continuously get their data with respect to their load, and then say, oh, it's overloaded, let me go start some more.
I see.
So that's sort of a process. Either we can put it in Skygate or SkyBridge, but we haven't done that yet. But as we scale, that's the idea. How we look at load of each of these sort of
Your
things.
point, right? That is a defense against a DOS kind of problem that we have, right? When we have too many Stargates talking to too few Skygates, we spin up more.
Okay.
And also, it's one more thing to do that. It doesn't right now. It just picks whatever is the registered one and returns it. In future, what we really want to do is also co-locate machines from the same cluster, same account to the same Skygates.
Sure.
So in the locate request, it actually sends its account ID. If we know that there's already Skygates handling those account IDs, we'll sort of say, oh, you also go it as long as the load is okay. So we can sort of try to more isolate, security isolation and get HIPAA certification and all that stuff.
There's some
Something like that.
scheduling problem there that to be solved, right? You can pick a set of preferred Skygates for a given account,
Right,
pick one out of those and things like
Well,
that.
then you can start doing things like regional data centers and
Yeah.
tie customer
Yeah.
to primary regional data center,
Yeah.
backup data center.
So if we front, for example, right, if we split the problem, registry needs to be fronted and it needs to be obviously
Global.
available,
Yeah.
right, globally available. Based on where the machine is connecting from, you can go different places. And also if you have multiple of these clusters, our Sky clusters running, it can also do the load balancing / active standby sort of thing. So it's like a split problem now. So at least if we keep this guy up as a split server service sort of thing, where it talks to each other, we can this we can do using other services. This doesn't have to be our processes. It will just be some DNS based, load balancer and other things that we do.
BGP or DNS
Yeah.
based. Yeah.
And then we can split this, okay, map to this guy. And like you said, maybe US goes to a different thing than, based on who is connected to. We might do registry.zerostack.eu rather than .com, but all of that stuff is all scalable. We can build it out.
Basically, the left-hand side abstraction stays intact.
Yeah.
Right? So you don't have to worry about that.
So that's why we have a discovery service rather than hard coding where to talk to and then fronting it separately, because we want to do more algorithms and scheduling and load balancing and more sophistication here over time,
Okay.
building up a SaaS service. Now, when we register this, right, the way this register and locate works is it just uses a registry module, which is in common. So it's common/registry. These guys over time it can't be abstracted, it'll get very dirty. But as of now, it just is a common registry thing which uses etcd to sort of store and load polls and everything, store and load the information about who's there. And the way these guys also work is, let's say you register and then you die, what will happen, right? How
Yeah.
does the SkyBridge know? So the way that right now the register works is it goes with a TTL. And the
I see.
TTL is something like 60 seconds. And then, the refresh, every 60 seconds it will go register, saying I'm still here.
Okay.
And every 180 seconds, the TTL is set to expire in 180 seconds. So within 3 minutes, if you don't report again, then this guy will expire this thing and don't know about your thing. It will mark it as this guy is not available.
Okay.
There is no mark as available, it just disappears.
This is a general heartbeat liveness problem.
Yeah.
You can't tell somebody you're alive if you're dead,
Yeah.
right? So then we put the onus on you to keep telling us that you're alive.
Yeah.
And it's again programmable. We do it, basically our standard TTL protocol is refresh and TTL equal to 3 times refresh. That's the usual stuff that we do. So right now, for example, Skygate is set to every 60 seconds and TTL of every 180 seconds. Okay. Now, there's another guy who does locate. Okay. And that guy is SkyMap. So this is Stargate, like we said, right? Which is doing this locate. SkyMap, the UI also does a locate. To locate, like, how do I talk to some specific cluster? So let's see how that whole process works. The user, this we talked about the Stargate handshake, right? Let's talk about how the SkyMap handshake works. At a high level, SkyMap is basically a UI backend. So it also right now is hosting the exact JavaScript UI files also.
Okay.
But over time, you can split that backend and file hosting separated out. So right now it has the Go code and the UI JS files also. So browsers are talking to it, right? The way we have structured our code is SkyMap uses something called Atlas, common/Atlas. Okay, and it uses this module to install and configure, and a lot of the code actually lives in Atlas itself. The reason we did this was there's actually a module called StarMap, which is not actively compiled and tested, which also just uses Atlas.
Okay.
And the idea is that the same UI that we run in the Sky, we should be able to take that same, most of that code, just run it on one of the nodes that's running in a ZVM and give it a local